Okay, so today we're going to discuss questions from the end semester test review for grade 8, semester 1. Okay, now for the first topic that we're going to discuss is about exponent. So before we go to jump to the questions, I would like you to understand these concept here, the one that we have already discussed at in classroom, right? So for example, like this one here, if we have like a to the power of x times a to the power of y, there'll be a to the power of x plus y. So just remember that we have already discussed how this works, right? So you can just like memorize all of this. Actually, you don't need to memorize it. You only need to understand on how it works. Okay. So okay, let's just jump to number one. And here we have 2 to the power of 2. Okay, simplify, read the instruction first. Simplify each expression into a single index form. A single index form. So in here we have 2 to the power of 2 times 2 to the power of 3. Now, the first thing that we need to see is whether they have the same index or the same base number or not. If they have the same base, then we can just add the power because this is a multiplication. So you can just add the power. So it's the same thing like this one over here, right? So in this rule. Now, in here we have 2. The 2 is from the one that I highlight, the 2. And the power is here, that will be 2 plus 3, right? This 2 and this 3. Just add them together and you will get 2 to the power of 5. Okay, it's that easy. Okay, the same thing for question number 2. We have 3 to the power of 4 and 3 to the power of negative 7. And as you can see that the base are the same, the 3. And which means that the 3 and then the power will be just 4 plus negative 7, and that'll be just equals to 4 to the power of negative 3. Oh, sorry, not 4. It should be 3. Yeah. So in here, as you can see that it doesn't matter if you have like a negative power for this one, because it doesn't tell you on like changing this into a positive index form. But if you want to do it, it's actually fine because we have this properties here, right? So if you have a negative power, you can like change it into like a fraction. So this just becomes 1 over 3 to the power of 3. Yeah, if you want, but you don't really need to do this. Okay. Okay, for number 3, it's the same thing, right? So we're multiplying some terms here, and all of them have the same exact index base number, sorry, and which means that it'll be just 7 to the power of negative 2 plus 6 plus negative 1, right? Negative 2 plus 6 plus negative 1. That's it. So yeah, just count that. It'll be 7 to the power of 3. That's it. Okay, moving on to number 4. And here we have a division. Previously we have multiplication, right? So if you have a multiplication, so you only need to add the power, right? So just make sure that they have the same base. Okay, the same thing with number 4 until number 5, for example. So here we have like a division, 3 to the power of 12 divided by 3 to the power of 7. And again, the first thing that you need to see is whether they have the same base or not. And here we have the same base, which is 3, right? So which means that we can just like subtract the power. So we have this rule over here, right? So that would be just 3 to the power of 12 minus 7, right? So just subtract the power. 12 minus 7 is equals to 5, so it's just 3 to the power of 5. That's it, right? The same thing for number 5. In here, the same thing you need to do is to see whether they have the same base or not. Here we have the same base, which is 5, and it'll be just equals to 5 to the power of 18 minus 19. That'll be just 5 to the power of negative 1. Okay, so number 6 is the combination of multiplication and division. So you can actually do this in a different way, but what I really used to do is to simplify the numerator and then simplify the denominator and then just combine them together. Yeah, so for this one, and here we have 11 to the power of 6 times 11 to the power of 5, and here we can simplify because they have the same base, which is 11. So I'm gonna simplify the numerator as 11 to the power of 6 plus 5, and then leave the denominator like that. Okay, and then you simplify this one, that becomes 11 to the power of 11, right? Because 6 plus 5 is equals to 11 over 11 to the power of 7. So now you can see that it has the same form as this one and this one, right? So what you need to do here is just subtract the power. So it'll be, I'm gonna move this a little bit to the left, not the right, sorry. And that'll be just 11 to the power of 11 minus 17, and it'll be just 11 to the power of negative 6. Okay. Now, for number 7, and here we have power rule, this one over here, right? This 2, number 7, 8. So notice that y in here we only need to like multiply the power. So because we know that if I have 2 to the power 4 to the power of 3 means that I am multiplying the 2 to the power 4 by itself 3 times, right? So actually it works like a multiplication. So this is like 2 to the power 4 multiplied by 2 to the power 4 multiplied by 2 to the power 4. Can you see that this is like a multiplication? And we have actually done that with this one, right? So the same concept applies here. So you only need to add the power, right? So if you add the power, that'll be like 4 plus 4 plus 4, which is equals to 12. So that'll be just 2 to the power of 12. But in here we can like, okay, so you can actually just multiply 4 and 3. You'll get the same exact thing, right? So when you do this in the exam, you only need to do it like this. So it's like 2 to the power of 4 multiplied by 3, and I use 2 to the power of 12. Okay, so the same thing with number 8, right? So we have power and then another power outside the bracket. That will be just 3 to the power of 8 times negative 2, which is 3 to the power of negative of 16. Okay, so number 9 is the combination of product rule, this one, and then the power rule, this one. Then again, guys, what I suggest you to do is, if you can simplify the one inside the bracket, do that first. Yeah, or you can actually do it in a different way if you want, but that's what I usually do. And in here I have this inside the bracket, which is this one, right? So you can see that this is like a multiplication and they have the same exact base number, which is 5. So we can simplify the one inside the bracket, becomes 5 to the power of 4 plus negative 6, right? So because this is a multiplication and they have the same exact base. So don't forget to write down the negative 3 outside the bracket here. And then you can see that you can simplify this, becomes 5 to the power of negative 2, right? Right, this guy becomes this guy. And then don't forget again that we still have this negative 3 as the power. And you can see that we are going back to here, right? And here. They're the same thing. So if we can simplify that by just multiplying the power, which is negative 2 times negative 3. And it'll be just 5 to the power of 6. Yeah. Okay, so for number 10, number 11, number 12, all of them have the same exact concept. Again, what I usually do is to simplify the one inside the bracket first, if you have a bracket, and then, yeah. So we can see that for this one, simplifying this sign in inside the bracket is the same thing like we just did over here, right? And over here, the same thing, right? So we only need to subtract the power, but again, remember that you need to have the same base. And here we have the same base, which is 2 and 2, right? The same thing, so it's 2. So if I simplify the one inside the bracket, it'll be 2 to the power of 13 minus 5, right? This one and minus this one. And then, don't forget again, we still have that negative 2 outside the bracket. And then simplify the one inside the bracket, there'll be 2 to the power of 8, right? 13 minus 5 is 8. And then the power of negative 2, this guy, still there. And then we only need to multiply the power. So 2 to the power of 8 times negative 2, and it'll be 2 to the power of negative 16, right? Okay, so I don't have to discuss number 11, right? So it's the same thing like this one. So I'm going to discuss number 12. Again, guys, you can do it in different way, but what I usually do is to simplify like the numerator first and the denominator, and then combine them, and then you can go to the power outside the bracket. So I'm gonna simplify this guy first, the numerator first, right? So that will be 3 to the power of negative 4 plus 9, because that's a multiplication. And then I'm going also to simplify the denominator by doing the same exact thing, right? So this guy here, that'll be 3 to the power of negative 1 plus negative 7, right? Okay, so notice that I'm doing it one by one. And then that to the power of negative 2 over 3 is still there. Don't forget. Okay, now we can just like add the power over here, which is just 5. That'll be 3 to the power of 5 for the numerator, and this one here, 3 to the power of negative 8. Again, to the power of negative 2 over 3. Okay, now we can simplify this one by subtracting the power. It'll be 3 to the power of 5 minus negative 8. So be careful with the negative, guys. It's minus negative 8. It's not minus 8. It's minus negative 8. And don't forget, we still have that 2 over 3. Okay, now add these two. You get 5 plus 8, which is 13. And then you only need to multiply these two powers. So remember that you don't have to write down as decimal. Just write this down as a fraction. So that will be 3 to the power of 13 times negative 2 over 3. And that will be just equals to 3 to the power of negative 26 over 3. And there we go. Okay, let's go to number 13. So, number 13 until number 16, all of them have the same exact concept, so expand in bracket. So remember that if we have something like this, we can use the FOIL method, right? So, like multiplying like this. 1, 2, 3, 4, right? And then try to simplify if they have like terms. Okay, so now let's do number 13. So I'm gonna do that first. So I'm gonna apply this x with x, which is going to be x squared, and then x times 2, which is plus 2x, and 1 times x, which is just plus x, and then 1 times 2, which is just plus 2. Now notice that we have like terms. These two terms are like terms, so we can add them together. They'll be equals to x squared, and then plus 2x plus 3 plus x is just 3x, and then plus 2. Right, so you can do the same exact thing with number 14 and 15 and 16. So I'm gonna skip 14 and 15 because it's the same thing. 16 actually the same thing, but I'm gonna show it to you guys. So again, 4x times 3x, there will be 12x squared, and then 4x times negative 8 is negative 32x. Be careful with negative. And then negative 7 times 3x, that'll be negative 21x. And then the last one is negative 7 times negative 8, that'll be plus 56. Okay, don't forget. Be careful with the negative. Okay, so we have these two terms as like terms, so you can add them together. There'll be 12x over here, x squared, right? Minus 32x minus 21 is going to be minus 53x, and the plus 56 doesn't change. Okay. Okay, number 17 until number 20, mostly the same, but you can actually use the calculator, guys, if you know how to do it. Actually, yeah, I did show you how to do it, right? Okay, now, but if you want to do it manually, that's fine, because, yeah. Here, we have factorize this. Okay, now, basically, when we're talking about factorize, it is the opposite of expanding, right? So instead of like doing here to here, you're doing the other way around. Okay, so so if you have a form of quadratic in which the coefficient of the x squared in here is 1, then you can do it like this. Okay, so for number 17 and 18, you can do something like this. Now pay attention for the constant. The constant is the one that doesn't have any variable in here, which is this one here. So that is the multiplication of two numbers, right? And then the one that has the coefficient of the x in here, this one here, that is the addition of those two numbers. So think of the two numbers. If you multiply equals 3, and if you add equals to 4, right? So that will be just 1 and 3, because 1 times 3 equals to 3, and 1 plus 3 equals to 4. Can you see that this 3 goes here, this one is here, right? So it's just 1 and 2, right? So both of them are positive, so we can just write down, oh, that will be just equals to x plus 1 times x plus 3. It doesn't matter if you write it down like this, guys. Yeah, the same thing. Yeah, the same thing. So you can just like, it's the same thing like if I have 3 times 2, that'll be just equals to 2 times 3, right? Yeah. Okay, so that is for number 17. Number 18 is actually the same thing, but you can see that this is a negative, so which means that if you multiply two numbers, you will get a negative number. So which means that one of them will be negative and one of them becomes positive, right? So can you see that if you multiply two numbers becomes negative 40, it can be like 1 times negative 40, or negative 1 times 40, or 2 times negative 20, and or 2 negative 2 times 20, and then what else, 4, yeah, 4 times 10, or negative 4 times 10, and then we have another one like 5 times 8, negative 8, and then negative 5 times 8. So we have a lot of possibilities now. If you do it again, if you do it manually, just think of these pairs and then just try to add them. Which one resulting 3, right? Okay, for example, if there's this one here, if you add them, they will be negative 39, right? So 1 plus negative 40 is negative 39. But this is not negative 39, so that those two are not the pairs, right? So if you do it one by one, you will get that this guy here, right? So negative 5 and 8 will resulting 3, because negative 5 plus 8 will be equals to positive 3. So this is positive 3. So these two numbers will be the answer. Okay, so when you write it down, they'll be equals to x minus 5 and then x plus 8, right? Negative 5 and 8, negative 5 and 8. Okay, so this is how you do it manually. So you can actually do it with the calculator, guys. Now I'm just gonna show you how to do it in calculator. I don't have the calculator. I do have the calculator, but maybe I'm gonna show that in other different video. Yeah. Okay. Okay. So you're using the FX991ES, and don't forget that we have that plus over here, right? So you can actually use other different type of calculator. Just make sure that they have the menu for solving quadratic. Okay, so if you use the quadratic, if you want to factorize it, for example, if you put this into that calculator, you go to mode. Oh, no, I'm second. Yes, now mode, and then you go to number 5, which is equation, and then you go to number 3, and then you only need to input the, what do you call it, the coefficient, right? So make sure that they are in a correct order. Yeah? The correct order is like we have the squared, and then we have the variable without the square, and we have the constant. So for this one, for number 1 here, and for this question here, what you need to put in after you go to mode and then 5 and 3, just input 1 and then press equal sign, and then 4 and then equal sign again, and then equal 3 and then equal sign again, and you will get x1, which is -1, and then x2, and then press equal sign again, you will get x2 equals to -3. As you can see that this number here represent these two numbers, right? So what you need to see is that, okay, if the answer in your calculator you get negative, so this is going to be positive. It's the other way around. If this is positive, then this is going to be negative. Okay, so again, if you can, I'm going to show you later on in a different video. Okay. Okay, next question, a little bit different topic. Simplify each expression as a single fraction. So, in here, guys, the first thing that you need to understand that you need to understand two concept. The first concept is how to simplify algebraic expression. For example, if I have like 2x plus 3x, they will be equals to 5x because they're like terms like x and x, right? It's the same thing like 2 apple plus 3 apple, they'll be just 5 apples, right? Okay, that's the first thing you need to understand. The second one is to understand the concept of fraction. For example, if I have like, let's say it's 1 over 8, and then plus, let's say it's 5 over 8, and then that'll be just equals to 6 over 8 because we already have the same exact denominator. Remember, if you add or subtract fraction, you need to make sure that they have the same denominator, and then you can add the numerator, right? So 1 plus 5 is equals to 6. 8, this is 8, you don't add them, so it's just the 6 over 8, and then you can simplify this fraction as 3 over 4 because both of them are divisible by 2, right? So you need to understand these concepts first before we before you can solve these questions. Okay, so let's go to number 21 here. The first thing we see is, again, this is simplify each expression. Okay, just simplify. Now we already know that if we add or subtract fraction, we need to make sure that they have the same exact denominator. Right here we have this 5 and then also 5, so they are exactly the same. So if they are exactly the same, we can just add the or subtract the numerator. So just 3x plus x, which is 4x, right? And then the denominator doesn't change, it's just 5. That's it. Pretty easy, right? Okay, how about if we don't have the same exact denominator, which is this one, yeah, 4x, 4 and 3, right? So in here, what we can do here is like to change so that they are the same, they have the same exact denominator. So how can we do that? We can do what we call the equivalent fraction. For example, if I have 1 over 2, I can actually change this into 2 over 4, right? Because I am multiplying with the same exact number, right? So we can do that. Now, if we are adding or subtracting, if you want to make the denominator the same, you need to find what we call the LCM, the lowest common multiple, or the least common multiple. So the least common multiple of 4 and 3 is 12, right? So make them so that they have the denominator as 12. Okay, so let's do it one by one. Here we go 4 to 12. So we need to multiply this by 3, right, to get 12. So you also need to multiply this by 3. So 3x times 3 is 9x, right? And then the same thing with this one, right? So 3, if you want to go to 12, you multiply by 4. So you also do the same thing with the numerator, which is this one. Just multiply that by 4, and you will get 8x, right? And don't forget, this is like addition, so plus over here. Okay, so that'll be just, okay, now we just add these two, like 9x plus 8x, they'll be just 17x, and then the denominator is just 12. That's it, right? So you can do the same thing with number 23. number 24, number 25 is actually the same thing, right? So the concept, this concept really, really is important for you to be able to simplify addition or subtraction of fraction. Okay, now let's go to number 23. Okay, now we have a different numerator, right? A denominator, right? So we need to make them the same because this is a subtraction. So now, what is the LCM of 8, and 12? That is 24. Okay, so make that 24 like that, right? And then you can see that, okay, I'm going 8 to 24. I'm going to multiply that by 3, right? So I also need to multiply this by 3, and you'll get 21x. Right, the same thing again with the other one, which is this one. The 12 goes to 24, you need to multiply by 2, right? So this also multiplied by 2, 5x times 2 is 10x. Now be careful here, guys, because this is a subtraction, so you also need to write down subtraction over here, right? Okay, that'll be just equals, okay, just 21x minus 10x will be 11x, right? And the denominator doesn't change, which is just 24. Right, so again, this concept is very, very useful for you to understand and be able to answer these questions. Now, number 24 and number 25 are the same, but be careful with this one because when you multiply, you need to multiply everything. Okay, so I'm going to show you how. So in here again, what we need to see first, if we have the same denominator and we don't have it, so which means that we need to find the LCM of these two numbers, which is 2 and 4. The LCM of 2 and 4 is just 4, right? So that'll be just equals to, I'm going to write down here, and that'll be just over 4 because, yeah, the LCM of 2 and 4 is 4. Now, again, I'm going to 4, I'm going to multiply this by 2. So we need to multiply everything over here by 2. Remember, it's not just the 5x, but this one here also needs to be multiplied by 2. So the way you write it down, right, systematically, so you should write it down like this. Because, okay, so multiply by 2, so it's going to be 2. Yeah, because you're multiplying this by 2, so 2, and then inside the bracket of 5x plus 1. Okay, so that's, yeah, that's how you do it. Okay, the next one is 4. And in the 4, you don't have to do anything because that's the same, right? So you only need to rewrite what's on the numerator, which is 3x. And then we just plus 3x. Okay, now we're not done yet because we need to like open this bracket. Oops, sorry. We need to open this bracket here, right? And then try to add it with 3x. Okay, so if we open the bracket, that'll be 10x plus 2, right in here, 10x plus 2. And then plus 3x over 4. So we can add them, we can combine the like terms, which are these two. They'll be 13x plus 2. Sorry, I'm gonna move this a little bit to the right. Okay, plus 2. And then over 4. So just remember, guys, the one that you can add are just the like term. I mean, like the one that can you simplify as addition or subtraction is just the like term. So remember that you don't combine this with 10 or 3. Okay, so just leave it there. Okay. Okay, guys, so number 25 is actually the same thing. So I'm gonna make the denominator becomes 15 because the LCM of 3 and 5 is 15. Now we can go to 3 to 15, you multiply by 5, so you multiply everything here by 5. So that'll be 5 bracket x minus 4. And the same thing with the other one, which is this 5. Okay, go to 15, you go multiply by 3. So you need to multiply every single thing over here by 3. So remember that we have a negative, that's not negative, it's subtraction. So it'll be subtracted by 3 bracket 3x plus 1. Again, where do I get this 3? Because 5 going to 15 is multiplied by 3. So that is where the 3 comes from. And then you can do the same thing like before. And here, just be careful that we have a negative here. So when you multiply, like going there and going there, that'll be negative. Yeah, so be careful with that. Okay, so let's do it one by one. So this is 5 times x, which is 5x. And then 5 times negative 4, which is minus 20. And then minus 3 times 3x, there'll be negative 9x. And then negative 3 times 1 is negative 3. Okay, can you see that we have a, what do you call it, like terms, which is this one and this one, which is 5x minus 9x becomes negative 4x. And then minus 20 minus 3, that'll be minus 23. And then over 15. Okay, so the next one is number 26. So in here, guys, what I really want to explain to you guys, don't ever do this. Okay, so but we have 2 over here and we have 2 over here. Cancel it. do not do that. Okay, that's illegal move. So why? Because they're not the same factor. We are like adding things here, right? So you don't do that. So you don't do like, okay, this is 2 and this is x, you can just cancel. No, you don't have, you cannot do that. Okay, but if I have like, for example, like x over times 2 and then x squared times 3x times 2, then you can cancel because they are being multiplied, right? X and x, yes, you can do that. But if it's like addition and subtraction, don't ever do that. So for number 26 until number 30, all of them have the same concept. In here we can actually factorize. So notice that what we did from number, where is it, wait, here you go, number 17 until number 20, we are factoring, right? So the same thing in here. So you can factorize either the numerator or the denominator or both of them, if you can do that, and then try to cancel any like terms. Okay, like same factor, sorry, not like term, any same factor. For example, if I write down 6 times 2 over 2, they'll be just equals to, if you do it manually, you can just, okay, 6 times 12 equals to 12 and divided by 2, and then you can say that 12 divided by 2 is equals to 6. You can actually just leave it like this, right? Just cross that because you can cancel it. It's just equals to 6, right? This is 1 and this is 1. 6 times 1 is 1, divided by 1 is equals to 6. Now again, when you have a multiplication like this, you are like you can cancel it. Another example, what if I have something like this: 6 multiplied by 1 plus 2, and then here we have 1 plus 2. So we can actually do something like this, right? Because, okay, we have addition, but that is addition is inside the bracket. So this guy and this guy is exactly the same. And this one is being multiplied by 6, and this is just like multiplied by 1. So this is also equals to 6 because we can cancel these two, okay? So this concept is also going to be very important for you guys, okay? Remember, do not do this, okay? Do not do that. Okay, the next thing that we're going to do is to factorize the denominator, because we have a quadratic over here, right? So if we do the factoring, that will be x plus 1 times x plus 2. Notice that we can actually put like this, and you can actually, we actually have a number in front. Remember, this is like 1 times anything is equals to the same number, right? Okay, now we can cancel, right? Because this is like, okay, it's the same exact thing and it's being multiplied by other things. Now this is just like 1 over x plus 1. That's it, right? So the same thing for number 27, 28, 29, and 30. So I'm gonna show it to you. So x minus 3, as the numerator doesn't change. This one here, if I factor it, that'll be like this. Okay, so you can see it in other videos if you want. And here we can cancel this because this is actually, if like, again guys, you can actually have that, right? So, and then you can cross this one and it'll be just 1 over x minus 5. That's it, okay? Same thing with this one. The one that we're going to factorize is the numerator this time, and there'll be x plus wait, it's 5, and then x plus 2, because, and then x plus 5 over here. Oops, sorry. And then we can see that we have the same factor here. Just cancel that, and it's just x plus 2. So notice that this is actually 1, but again, if I'm dividing anything by 1, you don't have to write it down. Okay, number 29 is the same thing again, but this time we need to factorize both numerator and the denominator separately. So if I do this, there'll be 10, there'll be 6 and 4, there'll be x plus 4, and multiply by x plus 6 as the numerator, and the denominator will be x 12, it'll be 4 and 3. 4 times x plus 3. Okay, now notice that we have the same exact factor, right? So we can cancel those two, and we will get equals to x plus 6 over x plus 3. Okay, can we do that? Okay, can we do this? No. Okay, so just leave it like this. This is 6 and 3. You do not do it like this, okay? Because again, they are being added. Okay, just leave it like that. Okay, you can try to do number 30 by yourself later, okay? Okay, next question is the topic of solving algebraic equation. So remember that the very basic concept is the first one is when you do an operation on one side of the equal sign, you do the same exact thing on the other side of the equal sign. That's the first thing. The second one is the goal is for you to have the variable alone in one side of the equal sign. So it doesn't matter whether it is on the right side or on the left side of the equal sign. Okay. Now here of number 21, we have x plus 2 over 4 equals to 5. Now, again, the concept is to make this guy alone in one side of the equal sign. The equal sign is over here. It's on the left side of the equal sign, but it's not alone. We still have 2 and 4 on that side, right? So we need to get rid of that 2 and 4. Now, the best way to do this is to multiply everything by 4. So if I do it like when we are learning in grade 7, they'll be like x plus 2 over 4 equals 5. I'm going to multiply this by 4, multiply this by 4, and then you can cancel it this, right? But for now, you don't actually need to write this down, and you only need to write down like this, right? Okay, now let's do it like that. Okay, now in here, the first thing you do again to remove that 4, so multiply everything on the left side and on the right side by 4, so there'll be x plus 2 equals to 5 times 4, right? And x plus 2 equals to 5 times 4 is 20. And then subtract both sides of the equal sign by 2 to get rid of this 2. So x equals to 20 minus 2, and x equals to 18, right? Pretty easy, right? Okay, the same thing with number 32, right? Number 32, in here we're multiplying both sides by 3. There'll be 2x plus 1 equals to 3 times 7, which is 21, right? And then subtract both sides by 1. There'll be 2x equals to 21 minus 1, which is 20. And then divide both sides by 2, and there'll be just equals to 10, right? So we've done this a lot, guys, so I don't really think I need to discuss this too much for you guys. So I'm going to skip number 33. I'm going to go to number 34. Now, number 34 has the same concept, but the only difference is that we have x on both a numerator and the denominator, right? So again, the first thing we do is like, okay, so basically sometimes you see that, okay, move this to the right. It's not moving, guys. It's multiplying with the same exact number or the same exact value. So in here we can do it like this. So that 3x plus 2, and multiply everything by x minus 7, right? So that'll be 3x plus 2 equals to 5 times x minus 7. Can you see that? X minus 7 here goes here, right? So put bracket, okay? If you don't put bracket, then you'll get the incorrect answer, okay? Because you're multiplying everything by that. So, okay, now we can open the bracket for the one on the right side. Remember, do it like this. 5x and then minus 35. Okay, now we still have a problem here. We have the x's on both sides of the equal sign. So you decide by yourself whether you want the x on the left side or on the right side. For me, this time I'm going to put the one on the right side. So which means that I'm going to subtract both sides by 3x. Okay, and then I'm going to okay, let's do it one by one. So this is like minus 35. The 2 stays there, but this 3x goes here, right? Subtract both sides by 3x. So I'm gonna like, okay, these two are like terms, right? So the 2 stays there, and 5x minus 3x is just 2x minus 35. Okay, now I'm gonna remove this one here, remove that one, just add both sides by 35. So this will be 2 plus 35 equals to 2x, right? So this goes here. Okay, now 2 plus 35 is 37. Okay, and then divide both sides by 2, and you'll get the final answer. So again, it doesn't matter where the variable is, as long as it's alone in one side of the equal sign, and the other equal sign, and on the other equal sign is like a value in the simplest form. Okay. Okay, number 35 until number 40, they're all the same thing, okay? So in here, this is like the combination of what we have done over here, right? Number 21, and also number 21 until number 30, and also number 31 until number 34, right? So you can see that we have on the left side of the equal sign is just like a fraction addition, and then on the right side is just like a single number or a single fraction, right? In here, what we need to do is like focus on one side of the equal sign. So if you can simplify the one on the left side of the equal sign, just simplify it. If the one on the right side is not simplified yet, you also need to simplify them. Okay, and then try to solve it like using an algebraic method that we always do. Okay, so in here we have this bracket here in which they are not simplified because we can actually combine these two, right? So remember when we did this question over here, number 21, can you see that if we have the same denominator, we can just like add the numerator, and then try to solve it. Okay, now let's simplify that one, the one on the left side of the equal sign. It'll be just 4x over 2, right? That'll be just 4x over 2. This one is just 3x plus x. It'll be 4x. And then remember that we already have the same exact denominator. Don't change it. And it'll be equals to 1 over 2. This guy over here, right? Now, you can actually simplify this because in here 4 over 2, we can simplify as divided by 2 you get 2, divided by 2 you get 1. So it's just 2x, right? So 2x equals to 1 over 2. Now, in here, we need to remove this 2, right? So we need to divide both sides by 2. There'll be x equals to 1 over 2 divided by 2. And then x equals to just 1 over 4. Okay, so you do the same thing for all of them, right? So for this one, you can try to do it the same exact concept as this one. Okay, so in here, I'll just go to the answer. 5x plus x is 6x over 6 equals to 7 over 24. This is actually easy because you know that we can like cancel this. It's just x equals to 7 over 24, and it's done because you have the x, the variable alone in one side of the equal sign, right? Okay, next, number 37. Okay, I'm gonna put it up here. 37. Again, we don't have the same denominator, so let's make them the same. It will be 15 because the LCM of 5 and 3 is 15. Okay, 5 goes to 15. You multiply by 3. So this also multiply by 3. You will get 3x. 3 goes to 15. You multiply by 5. This also means multiply by 5. So it will be plus 10x equals to 3 over 4. And that'll be 13x over 15 equals to 3 over 4. Now, because we want to find the x here, so the multiply everything by 15 and divide it by 13. So the easiest way to do this is like, okay, this goes up here, this goes down here, right? So the x, okay, I'm gonna highlight that, equals to that 3 over 4 doesn't change, right? And then that 15, okay, let me highlight that. This 15 goes here, right? It goes up. And that 13 goes down over here. Okay, I'm gonna highlight that using maybe green. I have green. Yes, we go. This 13 goes here. Okay, and then just do a simple operation. So 3 times 15 is 45, and 4 times 13 is 52. That's it. This is the simplest form of fraction, and that's it. Okay, so number 38, 39, 40, all of them are the same. I would like you to try it by yourself. Okay, so 40 is not, that's a little bit different, but it's actually the same thing. You can actually do it something like this, guys. So you can do what we call a cross multiplication. So I'm going to show you for number 38. Okay, number 38, I'm running out of space here. I'm going to make this a little bit smaller. Okay, I'm going to put it here. Okay, here we go. Now, number 38, I'm gonna try a different method, but actually it's gonna be the same. So the method we call it the I don't know, the butterfly method. I don't know. So we can like, okay, do this. Okay, multiply this here, and then multiply this here, and then multiply these two. Okay, so I'm gonna do one by one. Okay, so multiply this here. There'll be 3 bracket x plus 1. Right, that's the first one. The second one, I'm gonna apply this one over here. Because this is an addition, so just write down plus first, and then multiply the 4 with the 2x minus 1. 4 bracket 2x minus 1, right? And then the last one is to do the bracket, this one with this one. So it's just 4 times 3, which is 12, right? And then that 5 over 6 is still there, right? So equals to 5 over 6. Okay, so I'm gonna put some separator here, guys. That you can see. Sorry, my writing is not that good. Okay, now in here we are going to simplify again the one on the left side of the equal sign, right? So we're going to simplify everything over here. So because this 5 over 6 is the simplest form of fraction. Okay, now let's do the open bracket. Okay, that will be 3x plus 3, and this one becomes 8x minus 4. Okay, equals to 5 over 6. And then we can do 3x and 8x, which is 11x. And then 3 minus 4 is minus 1 over 12, equals to 5 over 6. Now this time, we're going to do what we call a cross multiplication. So this guy goes there, and this guy goes there. The same thing like we did over here, right? same thing. But just remember that if you have like terms like this, you need to put brackets. Yeah, that's going to be very, very crucial. So for this one, you will get 6 multiplied by 11x minus 1. So again, the 6 goes here. There'll be a multiplication. Don't forget to put the bracket. And it'll be equals to 5 times 12. So it's 5 times 12. Right, so this 12 goes there. Okay. So yeah, open the bracket again. You will get 66x minus 6 equals to 5 times 12 is 60. Now, this minus 6 goes to the right side. I mean, like, yeah, add both sides by 6. You'll get 60 plus 6. So 66x equals to 66. So x equals to divide both sides by 66, and you will get equals to 1. Okay, now you can try to do number 39 with the exact same concept. Actually, number 40 is the same thing, yeah, but be careful that we have x squared. But yeah, you can try it by yourself, yeah. Okay, I'm going to show you for number 39 here. So I've done the calculation, and this is the answer. Okay, so you can check your own working if you want. Okay, so I'm gonna explain number 40. So again, the basic are still the same, guys. So in here we have 5 over 2x plus 2 over 3x equals to 5 over 24. So simplify the one on this side of the equal sign first, on the left hand side. Now you can see that, okay, we have x and we have x, so you can actually find the LCM, which is actually just 6x, right? Or you can do the cross multiplication like before, but you'll get a problem with that. But yeah, I'm just gonna ignore that for you guys. So we can do something like that. So multiply this with this, multiply this by this, and then multiply this by this, and you will get 5 times 3x, right? And then plus 2 times 2x over 2x times 3x, right? Now, if we multiply that, it will be 15x plus 4x over 6x squared, don't forget, equals to 5 over 24. Now in here, 15x plus 4x will be 19x over 6x squared equals to 5 over 24. Now, in here we have x and then x here. Actually, we can, like, okay, if I have x squared, that is actually just x times x, right? So we can actually cancel one of the x, right? So we just like 19x. Okay, so yeah, 19 over, right? So 19 over 6x equals to 5 over 24. Then again, we can do the cross multiplication. So this goes here, this goes here, right? So it'll be 19 times 24 equals to 5 times 6x. Okay, so 19 times 24, let me use my calculator. 19 times 24 is equals to 456. Okay, that'll be equals to 5 times 6x, that'll be 30x. And then, which means that we only need to divide both sides by 30, right? And then you can just use the calculator. You'll get 76 over 5. There you go. Okay, and let's move on to the next topic, which is about function. Now in these question number 41 until 46, all of them are the same. I mean, like, they have the same concept. Now let's see the question here. Given the function of this, f of x equals to 8x plus 3, find the value of f of 1. So what you need to understand here is like this notation is f of x. It's not f multiplied by x. Okay, so be careful with that. Now in here, what that means is that, okay, we have x over here and then we have another x over here, right? So whatever happened to this, I mean, like, if you change this, for example, like becomes a, this also becomes a. If this becomes b, then this becomes b. If this becomes 1, and this is also becomes 1. So just remember that if when you do that, put bracket. Yeah, put bracket. So again, if I have f of x equals to 8x plus 3, so this x correspond to this x. Okay, so if this f1, so only need to substitute this x by 1. So remember that it's not 8 1, but you need to multiply by 1, right? So it's just 8 times 1 plus 3, which is just equals to 11. Okay, same thing with this guy, because this number 41, number 46 has the same function, which is this one for this question. Yeah, so that'll be just 8 multiplied by 8 plus 3, and then you can just calculate that, right? 32 plus 3 is 35, and so on, so on, so on, right? So this is like 8, negative 3 plus 3, and so on, so on, so on. Again, guys, you can use a calculator to calculate all of this. Okay, let's go to number 47 until 50. So the concepts are still the same, right? So we have the function of g of x equals to fx fx. It's 4x times minus 5, right? So again, whatever happened here, you change it here. So in here, find the value of a if this is what we're looking for in here, right? So in here, guys, what you need to do here is that the first thing we do is to change this x by a, because this is g of a. So I'm going to write that again. So I'm going to rewrite that again. So if g of x equals to 4x minus 5, is it minus 5? Yeah, it's minus 5. And which means that if I have g of a, it'll be 4a minus 5. Can you see what happened here? I just like changing this x becomes a, right? So for this question number 47, that'll be equals to 3. This one is the result. It's not the value of a. Okay, be careful with that. Okay, now can you see that we have an equation here? So just solve that equation. So you already done this a million times. So it'll be 4a equals to 3 plus 5, and then 4a equals to 8, and then divide both sides by 4, and you will get a equals to 2, right? So you do the same thing with all of these numbers, right? So I'm going to show you one more for number 48, for example. Again, just g of a again. So this guy here, the 4x minus 5, becomes 4a minus 5. So it's 4a minus 5 equals to 35. Again, it's dx becomes a because this is g of a. The function is this one, right? So yeah, that's it. So you only need to, again, solve the equation. So in here we have 4a equals to 35 plus 5, right? Add both sides by 5 to get rid of this one. So there'll be 4a equals to 40, divide both sides by 4, and you'll get 40 divided by 4, and a equals to 10. Okay, so you have done this a million times, guys, so yeah, you can do it. Okay, so I'm not going to discuss number 51 and 55, right? It's pretty easy. It's just a coordinates, right? Coordinates is x and y, for example. This coordinate of a is just 1 comma 3. This is 1 and this is 3. Don't forget that the x comes first before the y. So the x is the horizontal axis and the y is the vertical axis, okay? Now, let's go to number 56. Okay, if you determine the gradient from the line equation of that. So, whenever you see that a line equation has this form, right? So, the coefficient of x is the gradient. So, in here, we have the same exact form as this one, right? So, the y is alone in one side of the equal sign, and the other is on the other side of the equal sign. And then the coefficient of the x is the gradient. So this one is the gradient is equals to 2 because that is 2 over here, right? So this one is actually the same thing, which is equals to 1 because actually we have a number which is 1 over here, right? So for the next one is this is not 2, guys. It's negative 3 because as you can see that the gradient is the coefficient of the x, which is this one, right? Okay, so how about the number 59? For number 59, the form is not in this form, right? So just change that so that the subject is equals to y. So we can see that we can actually move this thing to the other side of the equal sign, right? There'll be the opposite operation of minus, which is plus. So change this becomes y equals to 2x. This is minus 2x becomes 2x, okay, positive. And the same thing with this one here, negative 7 becomes plus 7. Okay, can you see that we have the same exact form as the y equals to mx plus c? So the gradient is this guy over here. So the gradient of this line is just equals to 2. Okay, the same thing with this one. Again, make the subject so that the y alone in one side of the equal sign. And you will get the y equals to, I'm going to move this 3x and minus 1 to the other side of the equal sign. There will be minus 3x, right? And then minus 1 becomes plus 1. And as you can see that the gradient is just negative 3 because that is the coefficient of the x. Okay, so be careful with that. Okay, so if the form is not in this form, change it into that form and then take the what do you call it, the coefficient of x. Okay, let's go to this question here. Changing that, I'm gonna move that minus 3x and plus 10 to the other side, and that'll be 4y. Don't forget we still have 4 in front of the y, and equals to 3x. This is negative 3x becomes plus 3x, and plus 10 becomes negative 10. And we're not done yet because we still have that 4. So this 4 we need to get rid of by dividing everything by 4. Divide this by 4, you get just y. Divide this by 4, you get 3 over 4x. Divide this by 4, you get 10 over 4. You don't need to simplify this one. Just leave it there because we're not looking for the y-intercept. So as you can see that it's this guy here, that 3 over 4, is the gradient of this line. Okay, you can try to do number 62, okay? Okay, number 63 until number 66 is like the easiest question, I think. So right line equation that has a gradient of 1. So it doesn't matter if you can try, okay, this has a gradient of 1, right? Because this is 1. Or you can just like, okay, pi, I'm gonna add like plus 9, and that's the same thing. It doesn't really matter for this one, because the one that's being asked is just the gradient of 1. So the same thing with this one, for example. You can just write that, okay, that's just for x. Also, minus 1000, for example. That's the same thing. So both of all of these are the same. Yeah. Okay. Okay, number 67 until number 70. Exactly the same thing. Okay, remember that the form of y equals to mx plus c. Okay, and this form is what we call the gradient y-intercept form. Why? Because the coefficient of x is the gradient, and this guy here is the y-intercept. Here we have y-intercept. Okay, y-intercept. So y-intercept happens when the x value is equals to 0, because it's on the y-axis, right? So because if you see it like this, whatever point you have on the y-axis, the x will be equals to 0. Okay, so if it doesn't say anything about y-intercept, and you only you see a coordinate in which the x is equals to 0, so which means that that is going to be the y-intercept. Okay, so that's the first thing that you need to understand. So for number 67 till number 70, it's very, very easy, because you know that, okay, this is the gradient, this is the point of y-intercept. So just take these two numbers and you will get y equals to 3x plus 1. Can you see what happened here? I'm just like taking this 3 here and this one here. That's it. But remember that the form needs to be like this. Okay, second one, this one is also the same thing. Y equals to negative 5x. Don't forget the x. Yeah, this negative 5 here, and then this is 0 comma 4, so it's just plus 4, right? Pretty easy. This one the same thing. It's negative 3 over 4x, and then plus 9 over here, and this one over here, right? Very, very easy. Okay, let's go to the next question. Same thing over here. Right, this one will be y equals to negative 9x, negative 6. That's it. Okay. Next question, number 71 until number 73. Yeah, 71 until number 70. So, from the straight line above AB, above, determine the gradient. Remember that the gradient is just rise over run, right? So you can just pick two point on the line. Remember, on the line. Okay, so that'll be just rise over run, right? So you can go from A to B. How many rise do I have? It's just 1 unit, right? Going here, going from A to, wait, yeah, so it's like 1 unit, and then going there 3 units, so it's just 1 over 3. So remember that if you go uphill from the left to the right, it's going to be positive. If you go downhill like this, it'll be negative. Okay, so pretty easy. And then determine the point of y-intercept. The y-intercept is the point in which it passes through, it's on the y-axis, which is this one over here, and the coordinate of that line is just 0 comma 1. And then the last question is determine the line equation in the form of y equals to mx plus c. That is the same thing like we did from number 67 until number 70, right? So we have the gradient, and then we also have the y-intercept. So the line equation will be y equals to 1 over 3x, don't forget the x, plus 1. So this one is the gradient, this one is the y-intercept. Okay, so you can do the same thing with the next number, this one over here, right? Number 74 until 76. Okay, number 77 until number 79, they have the same exact concept. I'm going to show you number 77, and then you can try yourself number 78 and number 79. And I'm going to give you the final answer to check whether your answer is correct or not. Okay, so let's go to number 77. Determine the line equation which passes through point A and has a gradient of 2. So previously we are using that y equals to mx plus c, where the m is the gradient and the c is the y-intercept, right? So for number 77, you have the gradient, but you don't have the y-intercept. So we can actually find the value of c by using other point that passes through the line, which is this one. Okay, I'm going to show you how. So the first thing we do is to write down the formula, which is the y equals to mx plus c, right? And then try to plug in that we have already know, which is the gradient, which is 2. So this m becomes 2. And this point here, because it passes through the line, this will be the x and the y, right? So just plug in the x and y here, right? Okay, so the y is 3, so there'll be 3 equals to, the 3 comes from here, okay? This y. And then the x is 2, so 2 times 2, this 2 comes from here, okay? Don't Yeah, don't mix up. And this 2 here comes from here. Okay, so and then plus c. We don't know the value of c, so we can find the value of c by using this concept. So in here we have 3 equals to 2 times 2 is 4, and then subtract both sides by 4. That'll be 3 minus 4 equals c, and we know that the c is equals to negative 1, right? And then, which means that the line equation will be y equals to, because we know that the m or the gradient is 2, so it's just 2x, and then since we already know that the c is negative 1, so there'll be just 2x minus 1. That's it. Okay, I'm going to show you the answer for number 78, 79. Okay, so these two are the answer for number 78 and 79. You can check it by yourself. Okay, now let's go to number 80. Determine the line equation which passes through point A and B. Here we have point A 4,3 and B is 5,4. Now in here, remember that we can use this here again, but we don't have the gradient, we don't have the c. Now let's find it one by one. So remember that the concept of getting your gradient. So if you have like 2 points here that is not a y-intercept, okay, so it's 2.2 random points on the line, so you can find the gradient first and then try to find the c by using the same concept as we did for number 77. Okay, so for this one, let's find the gradient. The gradient is rise over run, or you can use the formula y2 minus y1 over x2 minus x1. Okay, so in here this becomes, for example, this is x1 and y1, this is x2 and y2, so they'll be equals to 4 minus 3, right? 4 minus 3, and then over x2 minus x1, which is 5 minus 4. 5 minus 4, which is equals to 1 over 1. 1 over 1 is just equals to 1. So the gradient is 1. Now, when you want to do the find the value of c by using this concept here, like we did over here, right? So you can use the same thing, the exact thing, but the point that you will pick, you actually, like, you have an option. It's up to you if you want to use this point or this one. It doesn't really matter. You will have the same exact answer. So again, if y equals to mx plus c, now we already know that the m is 1, right? The gradient is 1. It's just 1x or just x, and then plus c, and then just plug in one of them. For example, I'm going to use this one, and there'll be a 3 equals to the x is 4 plus c. So in here, that'll be a 3 minus 4 equals to c, so c equals to negative 1. So if I'm using this point, it will be the same thing. Okay, so let me prove it to you. So this 4 becomes the y, so 4 equals to the x is 5, so it's 5 plus c. That'll be 4 minus 5 equals c, and c is equals to negative 1, right? It's the same exact thing. So which means that the line equation will be y equals to 1x, because the gradient is 1, but you don't need to write down the 1, so it's just x, and then minus 1, because the c is minus 1. Okay, so you can do the same exact thing for the number 81 and 82. You can pause the video now and try to do number 81 and 82, and then go back to the video and then to see the final answer. Okay, so for number 81 and number 82, these two are the final answer. You can check your answer and check whether it is true or not. I hope you get it correctly. Okay, so let's now go to number 83. I'm gonna put this here, guys. Sorry. Yes, okay, solve this system of simultaneous equations. So in here we can use a substitution method or elimination method or graphing method, or you can use the calculator. Okay, so again, I'm gonna do the tutorial on the how to solve this using the calculator in the different video. Okay, now for this one, if you're using the elimination method, just make sure that they have the same exact form. For example, like x and y, and then x and y, and then equals to a number, right? So that is what you need to do first. Okay, now in here, the first thing that we need to do is that we need to determine which variable do we want to eliminate first. For example, the first one here, I'm gonna eliminate the x, right? So how can I eliminate the x? By just subtracting them, okay? Because if I subtract them, x minus x is just equals to 0, right? So it's eliminate the x. 0x is just 0, okay? So I'm gonna subtract those two equation, right? Okay, x plus y equals 7, and x plus, it's minus y equals to 3. Now if I subtract that, x minus x is just 0, eliminating, and y minus negative y is 2y, and then 7 minus 3 is equals to 4. So you can see that divide both sides by 2, you'll get 4 over 2, and you will get equals to 2. right? So how can we find the value of x? Just plug in this y to one of the equation. So it can be this one or this one. It will be the same. So just pick one of them. Okay, so I'm gonna pick this one here. For example, x plus y equals 7. So if I have x plus y equals 7 and I know that the y is 2, so just change this. Substitute that to substitute that y becomes 2. So x plus 2 equals to 7. So x equals to 7 minus 2, which is equals to 5. Okay, now can you see that these two numbers, these two values of x and y, will can be applied to do both of these equations. For example, like this one. If this is 5 and 2, that'll be 5 plus 2. 5 plus 2 is equals to 7, right? And then again, this one is 5 minus 2, that'll be equals to 3. So it will have the same exact what do you call it, it will be applied to both of these equation. Okay, so yeah, this is for number 83. Okay, the same thing with number 484. Here we have these two equation. So for this one is again it's pretty easy because we can just like eliminate the x by just adding these two equation, right? So because x plus negative x is equals to 0. So notice that previously we are subtracting, because again the concept is to eliminate one of the variables. Previously we are subtracting because x minus x is equals to 0x, right? It's just 0. For this one, if you try to subtract it, so x minus negative x, they'll be minus 2, they'll be, sorry, it'll be 2x. So you're not eliminating the x, because if you subtract this one also, there'll be 7y. So we are not eliminating one of the variables. So again, for this one, you need to add, because again, the concept is to eliminate one of the variables. So if I add them, this two becomes 0x. It's just 0, right? And then if I add these two, there'll be 3y plus negative 4y. There'll be negative 1y. And if I add these two, there'll be negative 7. Yeah. And because we have a negative 1 here, so divide both sides by negative 1. So y equals to 7. That's it. Okay, so again, to find the value of y, to find the value of x, the other variables, just plug it into one of the equation. I'm going to use this equation here. So I'm going to plug in the y by 7. That'll be x plus 3 times 7 equals to 18. So 3 plus 21 equals 18. So, sorry, it's not 3. Sorry, my bad. This is x. X plus 21 equals to 18. So x equals to 18 minus 21, and x is equals to negative 3. Okay, so this is the same question, but just a different equation. So for this one is we need to do something first before we add or subtract, right? So previously we know that by using the elimination method, we can just like subtract or add and then eliminate one of the variables, right? For this one, if you add, for example, this one becomes 12x, this one becomes negative 3y. It doesn't eliminate any variables. It still have x and y. If I subtract, and if I subtract 7x minus 5x becomes 2x, minus 4y minus y is minus 5y. So I'm not eliminating any of the variables. So what we need to do first is like, okay, to find, to determine which variable do we want to eliminate. I'm going to, the easiest one for this question, I think, is I'm going to eliminate the y, because if I multiply the second equation, every single of them by 4, I will get this. 20x. Okay, multiply this by 4, you get 20x. Multiply this by 4, you get plus 4y. And multiply this by 4, you get 88. If I rewrite this equation again exactly below this equation that I just do, and you can see that if I add them, this guy becomes 0, right? Because this 4y plus negative 4y is just equals to 0. I'm eliminating this y, right? So okay, just do that. Okay, so 20x plus 7x is 27x, and this is gone because it's just 0, and this becomes 81, right? 88 plus negative 7 is 81. So x equals to 81 divided by 27, and x equals to 3, right? Okay, so again, to find the other variables, just plug this x into one of the equation. I'm gonna use this equation. Okay, so 5 times 3, right? The x is 3. And then okay, and then plus y equals to 22. 5 times 3 is 15, and which means that the y is just 22 minus 15, and that will be just equals to 7. Okay, so to the next, move on to the next question, which is the essay. In here we have number one, line L1 has an equation of y equals to 2x minus 1. What is the gradient of line L1? So we have done this before, right? So the m, or the gradient of this line, m1, because it's L1, is equals to 2, because we know that this is the gradient, because we already have y equals to mx plus c as the form of that equation. Okay, now let's go to the next one. And line L2, we have another line, passes through point A and parallel to L1. So if we're talking about parallel and perpendicular, so if they are parallel, so the gradient of, for example, line L1 and L2 are parallel, so they will have the same exact gradient. Okay, so remember that gradient is the same thing as slope. For example, if I have this line, let's say the slope is 2, and I have another that is parallel, so this line has also the gradient of 2, because they have the same exact slope. Okay, so again, but if they're perpendicular, let's do for number 2 later on. If they're perpendicular, and then perpendicular means that it will form a 90-degree angle. So if the m1 is equals to a over b, then the m2 will be equals to negative b over a. So it's just like we call it the negative reciprocal. So for example, if this is like 2 over 3, this becomes negative 3 over 2. That's it. Okay, now let's do for number 1 here. There it said that it is parallel. It means that the gradient of the second line is also going to be equals to 2, right? Because they're parallel. Okay, and the next one is construct line equation. We have already done this before, so this becomes the x and y, right? And by using the same concept, y equals to mx plus c, and then find the c by just putting the 2 onto the m, and then putting the x here, which is 3, and then putting the y is negative 2, right, plus c, and it'll be negative 2 equals to 6 plus c, and negative 2 negative 6 equals to c, so which means that c is equals to negative 8, and which means that the line equation of the second line will be 2x minus 8, because in here the 2 comes from the gradient, and this minus 8 comes from here, which is the c, right? So we can do the same thing with the second question here, right? Second question are actually the same thing. Now, line L1 has an equation of y equals to 2x, 2 over 3x plus 4. Again, because it is in the form of y equals to mx plus c, just take this value here, this one, 2 over 3, as the gradient of the line. So what is the gradient of line L1 is just 2 over 3. Just this guy over here, right? Oh, without the x, okay? Just, yeah, leave the x alone. And then line L2, another line here. This is a different question. Passes through point this and perpendicular to line L1. So which means that we can use this concept over here, right? If they are perpendicular. So if the first gradient is 2 over 3, and then the other gradient of the line that is perpendicular to that line is going to be negative 3 over 2. Can you see that? I'm just like swapping the 3 and 2. And then if this is positive, if the one is positive, the other is negative. So the logic is like this. If one is going up, the other must be going down, right? Because 90 degrees is like this, right? So it's going down, so negative. This one is going to be positive. Okay, so we can do the same exact thing like before. I'm not going to show you how to do it. You can do it by yourself. I'm just going to show you the final answer. Okay, so this is the final answer for question number 2. Okay, let's go to number 3. Okay, so the cost of 1 kilogram of sugar and 2 kilograms of salt is 50,000 rupiah, while 3 kilograms of sugar and 3 kilograms of salt cost 70,000 rupiah. Using the information above, and given that the x is the price of 1 kilogram of sugar and y is the price of 1 kilogram of sugar, construct two algebraic equation in terms of x and y. So let's convert this sentence into an algebraic equation. Now we already know that the x is the price of 1 kilogram of sugar, so 1 kilogram of sugar is just x, right? And then the y is the price of 1 kilogram of sugar, so it means that if you have 2 kilograms of sugar, it's just 2y. So if you add them together, right, the cost of 1 kilogram of sugar and 2 kilograms of sugar is equals to 50,000 rupiah. Okay, so that is for the first equation. The second equation, the same thing like we do, right? So the sugar is the x and the salt is the y. So we can say that this is 3 and this is 2. So it's just 3x plus 2y equals to 70,000. Right? Pretty easy. Now, this is the same thing as like we did for the simultaneous linear equation, this one, right? So we can just like, okay, just eliminate that, because this one is pretty easy because you only need to subtract, because we already have the same what do you call it, coefficient for the y here, which is 2 and 2. So by just subtracting these two equations, you are eliminating the 2y, right? The y. So x minus 3x is minus 2x. 2y minus 2y is just 0. 50,000 minus 70,000 is minus 20,000. Then divide both sides by negative 2, and you will get equals to 10,000 rupiah. Okay. So yeah, sorry, that's for A. This is for question A. Sorry, that's for this is question B. So question B is here to using substitution or elimination method determine the value of x and y. So we have already determined the value of x. Now find the value of y by just substituting this 10,000 to one of the equation. I'm gonna use the first equation, and there'll be this x becomes 10,000. So that'll be 10,000 plus 2y equals to 50,000. Right, so 2y equals to, just subtract this by 10,000, you will get 40,000, right? And then divide both sides by 2, and you will get 20,000. So the price of 1 kilogram of sugar is 10,000. The price of 1 kilogram of salt is 20,000. Okay, in rupiah. Now the last question is the price of 4 kilograms of sugar and 3 kilograms of salt. Now since we already know the price of 1 kilogram of sugar is 10,000, and the price of 1 kilogram of salt is 20,000. So this will be like 4 times 1 10,000, and then plus 3 times 20,000, right? And that'll be just equals to 100,000 rupiah. Don't forget to write down the rupiah. Yeah. Okay. Okay, so for number 4 and number 5, actually we have the same exact concept as number 3, but the thing that you need to do to really know how to do is to convert the sentence into an algebraic equation. That is the main thing that needs to do, because when the calculation, you can use the calculator. Yeah, okay. So let's read number 4. Number 4 and number 5 is exactly the same thing. Okay, so let's construct the equation. Okay, so the tickets to the fair cost $5 per children and $15 for adults. On Monday, 169 people entered the fair and they collected $1,665. What number of children and what number of adults attended? So let's say the total number of children that attended is x, and the number of adult is the y. So we can see that, okay, so this cost and also cost, they'll be like connected into each other. Okay, so since we know that one ticket for children is $5, so if x number of children goes into that to that fair, then the total number of money that collected from the children is just $5 multiplied by the number of children, right? So that'll be like 5x, right? 5x. And the same thing with the adults, right? So we have $15 for one adult. So if y number of adult attended the fair, there'll be just plus 15y, right? And then this connected to this one, 1665. 1665. There you go. We have one equation. Okay. What's the next equation? Is here. On Monday, 169 people enter the fair, right? So it means that it is the sum or the total number of children and adult altogether. So this guy here, this sentence here, it means that there will be x, the number of children, plus the number of adult is equals to 169. Can you see that we have like two equations, and you do the same exact thing like we did for number 3. Okay, I'm gonna show you just the final answer. Okay, here we go. So this is the final answer for number 4. So yeah, x and y, but you need to write down the final answer in sentence, because I don't know if I'm the teacher. I'm correct. I'm checking your answer. I don't know what is x and what is y in this context. It can be the x can be the adults. It can be the children. Right? So you need to write down the sentence. Okay. There are for example there are 82 children and 87 children and 82 adults. Now for number 5, it's actually the same thing, right? So number 5, we do the same exact thing. So the equation that we have will be 5x plus 10y equals to 1390, right? So 5x plus 10y equals to 1390. That's the first one. The second one is 183 people entered the fair, so it'll be x plus y equals to 183, and then you do the same exact thing. You will get the value of x and y. Okay, so the value of x and y, again, you can use a calculator later. Okay, so the x is going to be, what was it, 88, and this is going to be 95. Okay, then again, you can write down the conclusion as a sentence. So there are 88 children and 95 adults. Okay. Okay, number 6. From each of the equation below, find the value of x. So, in here we have an exponential function. Now, when you want to solve this kind of equation, just make sure that the left side and on the right side of the equal sign has the simplest form of expression, and also they have the same exact base number. Okay, so for example, number 6, we have the same base, right? 3 and 3. So which mean, and they are, this one is the simplest form of expression. This is also the same thing, right? So it's just like a single index form. So which means that we can actually just take, okay, so which means that if they are the same base, so this guy becomes equals to this guy. So there'll be just 4x equals to 20, and divide both by 4, and you'll get equals to 5. That's it, right? So that's for question A. So question B is actually the same thing, but we have a problem here. We don't have the same base. So change so that they have the same base. Now we can change the 9 by 3 to the power of 2, right? So I'm going to change this 9 becomes 3 to the power of 2. But don't forget that we still have that x over here, right? So put the x like outside the bracket like this, okay? That'll be equals to 3 to the power of 5. It doesn't change. Now we can see that we have the same base, but we still have a what do you call it? The parentheses, yeah, or the brackets. Now open the bracket. Remember that you only need to multiply this here, right? So there'll be 3 to the power of 2x equals to 3 to the power of 5. Now we have the same exact base without any brackets. Now let's just take this guy and this guy. So there'll be 2x equals 5, and x just equals to 5 over 2. Right? That's it. Okay, the same thing for number C, D, and E. All of them are the same. So I'm gonna do the C here. This 8, this is 2. They're not the same, so we make the same. So I'm gonna change this. Becomes 2 to the power of 3, because 2 times 2 times 2 is equals to 8, right? So there'll be 2 to the power of 3, right? This guy. And then that 2x here is still there. That 2x. And on the right side, this one doesn't change because yeah, okay, now we have the same exact base, but we're not done yet because we have a bracket. Now open the bracket first by multiplying these two things here. Yeah, and that'll be 2 to the power of 3 times 2x becomes 6x, and it goes to 2 to the power of 18. Okay, now we have the same exact base, and then they're in the simplest form, so just take these two. So that'll be 6x equals to 18, right? And divide both sides by 6, and you will get equals to 3, right? So the same thing with number D, E, but be careful that if we have this, meaning that we need to like multiply everything by that. But yeah, okay, I'm gonna go to E this time. I'm gonna answer the D. Just yeah, you can pause the video and try to solve D. I'm gonna show you the answer. Okay, so this is the answer for question D, which is x equals to 7. Okay, so now let's go to number E. So actually it's the same thing. Remember that the concept is like make so that they are the same. So this is 16 and 8. So, okay, we can we like do this becomes 8 to the power of something? No, because 8 to the power of 3 is not 16, right? So instead of like just changing one of them, why don't we change it both of them? Because we know that 16 is 2 to the power of 4, and this is 2 to the power of 3. Now we have the same base, right? So we can change both of them right down over here, and that'll be the 16. I'm going to change it into 2 to the power of 4, and okay, I don't think it will fit. I'm gonna move it a little bit down here. Okay, and then remember that 2x is still there, this guy is still there. And then on the right side, equal for the equal sign, there'll be 8. I'm going to change this 8 becomes 2 to the power of 3. Okay, 2 to the power of 3. Okay, don't forget we still have this guy here, 3x minus 1. Okay, just rewrite that again, 3x minus 1. Now they have the same base, but we still have brackets, so open the bracket. Now by just multiplying, or this one, multiply 4 times 2x becomes 8x, right? 2 to the power of x. And on the right side, the same thing, but be careful. This 3 must be multiplied by both of these two terms, okay? So I can just write down like this, okay? So 2 to the power of 3 times 3x minus 1, right? So this one is just going straight because we only have like one term, and yeah. So in here, we have the same, okay, maybe I'm just gonna open the bracket again, and that'll be 9x minus 3, right? Now we have the same base, and we open all the brackets, and then they're in the simplest form, and on the right side, left side, on the right side. So let's just take the power, which is 8x equals to 9x minus 3. Just take this equals to this, okay? Because they have the same exact base, okay? Now I'm gonna move that 8x to the right side. I'm gonna move minus 3 to the left side. There'll be 3. This becomes positive, going there. And then 9x stays there. And this 8x moves to the right side. There'll be negative 8x, right? 9x minus 8x is just 1x, so it's just x. And there you go, you have the final answer. Okay, so this question is again the same thing. So the concept is to make each side of the equation have the simplest form of expression, and then if you want to combine, if you can combine like terms or like index form, just do that. Okay, so just make sure that both sides have the same exact base number, and also they are in the simplest form of expression. Okay, now let's focus on the left side first. Okay, so I'm gonna do the left side first, and here we're going to simplify that. Okay, so in here we do not have the index form, I mean like the base number is not the same, but we can change that 8 becomes 2 to the power of 3, right? So this 2 doesn't change, and I'm gonna change this 8 becomes 2 to the power of 3, right? It'll be 4x plus 1. I'm not going to change anything on the right side yet. And then this becomes 2 times, again, we can multiply these two, right? Just multiplying by doing this one, right? That'll be 2 to the power of 12x plus 3. Okay, now again, because this is a multiplication, you can just add the power. So remember that we don't see any power here, right? So actually we have, which is 1. You don't really to write it down. So if I just write down 1 here so that you can see what happened here. So that'll be 2 to the power of 1 plus 12x plus 3, right? Because it's just like adding these two power. So that'll be just 2 to the power of 12x plus 4, right? Because the 3 and the 1 are like terms, it's just like that. Okay, now we're done on the left side. It's a single index form, right? And it is the simplest form of expression. Now we do the same thing on the right side of the equal sign. Now we don't have, now we already choose that the index, not the index, the base number is 2. So why don't we make this into 2, right? So 32, you can use a calculator. I mean, like, how many 2 do you need to multiply to get 32? The answer is 5, because 2 to the power of 5 is equals to 32. Okay, now let's change that 32 becomes 2 to the power of 5. So this guy becomes 2 to the power of 5. And you can see that we still have the x over here. So it's just x and multiply by 2 to the power of 5. And then we can simplify this again, guys. Just focus on that side of the equal sign. So multiply this 2. You get 2 to the power of 5x, because you need to multiply this. And then multiply that 2 to the power of 5. And then you can see that we can just add this power, right? 2 to the power of 5x plus 5. Okay, now in here, this is like the simplest form, so you can just like rewrite that equation again so that you are in the same line with this one. Okay, now here, now we have the same exact base number, right? And it is in the simplest form of expression. So now we only need to take the power. This one equals to this one, right? So it'll be 12x plus 4 equals to 5x plus 5. I'm going to move that 5x to the left side and 4 to the right side. That'll be 12x minus 5x equals to 5 minus 4. And there will be 7x equals to 1. So x equals to 1 over 7. Okay, so next question here. So remember what I always said, guys. So if you have like an equation like this, so just make sure that you are simplifying things. Okay, so for this one, the one on the right side of the equal sign, 2 to the power of 2 is the simplest form of the index form, but on the left side of the equal sign is not the simplest form, so we can simplify this first before we combine with this one. Okay, so let's do that. Okay, here we have 2 to the power of 3x times 2 to the power of 4 over 2 to the power of 5. You can actually like do it like in one go, but if you're still confused, you can see like, okay, let's do it one by one. you simplify the numerator first. So we have 2 to the power of 3x and then times 2 to the power of 4. Remember that if you are multiplying and we have the same exact base number, just add the power. So this becomes 2 to the power of 3x plus 4. Okay, the one on the bottom doesn't change. Okay, this one, because it's the simplest form of the index form, just leave it like that. Okay, now there's a lot of way in how to do this. You can like combine this one and this one, or you can like move this to the other side. Becomes 2 to the power of 5. It's actually the same thing, right? So again, you can have different method, but remember that it needs to be systematic, and you have the final answer as the correct answer. Yeah, okay. So what I'm gonna do here, I'm gonna combine this two first, right? So yeah, they'll be just subtracting the power, right? So subtract this one and this one, because we already have the same exact base, which is 2. So that'll be 2 to the power of 3x plus 4 minus 5, right? And that'll be minus 1, right? Okay, now we have the same exact base number, and then it is in the simplest form of expression, so we only need to take this, right? So that'll be 3x minus 1 equals 2. I'm going to move that minus 1 to the right side. That'll be 3x equals to 2 plus 1, which is 3. And x is just equals to 3 divided by 3 is just equals to 1. Now, like I told you before, you can actually move this to the right side. And we can see that actually you will get the same exact result. So if I'm going from here, from this process, if I move that 2 to the power 5 going to the right side, I mean like multiply it both sides by 2 to the power 5, there'll be 2 to the power of 3x plus 4 equals to 2 to the power of 2, and that 2 to the power of 5 is going to be multiplied. This one here goes here, right? So yeah, again guys, this is just a different method. Okay, so if you want to use this method, it's fine, and if you want to use method, this is also fine. Okay, and here we still have like this, and this is, again, you only need to add, right? 2 plus 5 is just equals to 7. So 2 to the power of 7. Now, we have the same exact base. Now, we only need to take the power, which is this guy and this guy. So it's 3x plus 4 equals to 7. And 3x equals to 7 minus 4, right? 3x equals to 3, and x equals to 3 divided by 3, and x equals to 1. And so you can see that the answer are the same. So you can choose any method you want, as long as it is systematic, and you'll get you get this the correct answer. Okay. Okay, so you can try for this question with using the same exact concept like I just shown you before. You might want to pause the video and try to do it, and then see the final answer after this. Okay, so this is the final answer for question H. Okay, now moving on to the next question here, number 7 and number 8. I'm not going to explain it because I have already explained it to you guys from the previous video. You can check that again. Number 7 and number 8 is the same exact type of questions. I'm gonna go to number 9 and number 10. Okay, now in here number 9, we're going to use a quadratic equation, right? So in here, a right angle triangle has a dimension as shown below. This is the dimension. By using the Pythagoras formula, we know that is c squared plus a squared plus b squared. Calculate the possible value of x. And here we have this. Now, when you have a right angle triangle in terms of the Pythagoras formula, so this c here, that is going to be the longest side, or the side in front of the 90 degrees. So that is going to be the c. Okay, do not mix that up. The c is not this one, not this one. For this formula, again, if you add them up, so why is it here? Why is it here? Because that's the longest side. Can you see that this one and this will always be the longest side? And if you see it from the formula, if you're adding like two numbers, so for example, this is 1, this is 2, and this is equals to 3. So this number is always going to be larger than these numbers, right? Because you're adding two positive numbers, right? Because as you can see that a number that's being squared is always going to be positive, right? Positive number plus positive number equals to positive number. And if I highlight for it, 3 plus 5, they'll be equals to 8, right? So these two numbers are smaller than these two, right? So that means that this is going to be the longest side. That's why the c is going to be like this one here, over here. It's in front of the 90 degree. Yeah. Okay. Now for this one again, determine the c, a and b. So the c is going to be here. So the a and b doesn't really matter which one is which. So I'm going to say this is a and this is b. It doesn't matter. You can say this is a and this is b. It doesn't really matter. So the one that is matter is the c. Okay. So let's name that. I'm going to name this as a, and I'm going to name this with b, and this is the c. Okay, so I'm gonna read that. So a is going to be x, the b is going to be x plus 2, and the c is going to be 2x minus 2. Okay, from all of these things, right? Okay, so yeah, so a is this one, and then b is this one, and the c is this one. Okay, so now we're going to plug this value of a, b, and c onto this formula. Okay, so I'll change the c by 2x minus 2. So that'll be, I'm gonna write down the formula first here, guys. So I'm sorry, just gonna use okay, shapes. It's lagging. Okay, move that a little bit to the right side. Oh, sorry. Okay, now I'm gonna write down the formula first, which is the c squared equals to a squared plus b squared. I'm gonna change the c becomes this guy, 2x minus 2. So don't forget the bracket, yeah? So that'll be 2x minus 2 squared. And then equals to the a, which is this one. So again, you can use the bracket. You don't have to use bracket for this one because it's like a single number or a single form. And then the last one is the b, which is this one, x plus 2. And this one needs to be in bracket because we have two terms inside the bracket. It's like this, right? So now we only need to expand the bracket. So remember that 2x minus 2 squared means 2x minus 2 times 2x minus 2. So I'm gonna just like write it down for you guys. So if I have 2x minus 2 squared, that'll be equal to 2x minus 2 multiplied by 2x minus 2. Don't forget this concept, yeah? Be careful with that. Okay, I'm gonna rewrite that for you guys. So that'll be 2x minus 2 multiplied by 2x minus 2 equals to, this one is just x squared because x squared is just x squared, and this one becomes x plus 2 times x plus 2. Again, we can do the FOIL method again, guys, like we did before. This will be 4x squared minus 4x minus 4x plus 2, and on the right side the x squared doesn't change. This becomes x squared plus 2x plus 2x plus 4, right? So we do this, right? 1 2 3 4. Okay, so yeah, I'm not going to slow it down for you guys because you already know how to do it. Okay, now simplify each of the expressions. So this one on the left side becomes like this, and then on the right side we have 2x squared because this one is 2x x squared plus x squared, and then plus 4x, and then plus 4. Now in a quadratic equation, you need to write it down as the form of ax squared plus bx plus c equals to 0, meaning that one side of the equal sign consists all of the terms and the other is just 0. So let's move everything here to the left side, right? So move everything there to the left side. So I will get 4x squared. So maybe I'm gonna change the color so that you can see what happened here. Okay, here we go. I'm gonna change it to blue. Okay. Okay, so 4x squared minus 8 squared, minus 8x plus 2 doesn't change, so I'm gonna move every single thing on the right side. There'll be minus 2x squared, and then minus 4x, and then minus 4, and everything goes to the left side, and then meaning that on the right side we have nothing, which is 0, right? So what happened here? This is 2x squared becomes minus 2x squared, and then 4x plus 4x becomes minus 4x, and then plus 4 becomes minus 4, right? Okay, now we can collect the like terms, this one with this one. 4x squared minus 2x squared is just 2x squared. And then minus 8x and 8x and minus 4x, they'll be minus 12x. And then plus 2 minus 4, that will becomes minus 2 equals to 0. Okay, now a lot of way in how to do this. You can just like do factoring, or you can do the ABC formula, which you haven't learned yet, guys, but I suggest just go to the calculator and you'll get the x1 and x2. Yeah, so if you go to the calculator, you go to mode and you go number 5, and then number 3, and just plug in all of the numbers. If I do that, that'll be okay, 5 and then 3, sorry, mode 5 and 3. Okay, so that'll be 2 and then negative 12 and then negative 2. You'll get the x1 is equals to, wait, is it correct? Wait, let me check. Okay, guys, I made a mistake. This one should be 4, right? My bad. Sorry, guys. 2 times 2 is 4. Okay, I'm gonna change that. Yeah, human error, guys. I'm a teacher. I'm also human. So I can be mistaken for, yeah, okay. So which means that this is not plus 2, right? So this is plus 0. It's just nothing because plus 4 minus 4 is just 0. Now again, so which means that this is, if I'm just gonna write that down, this is actually okay. So because this is like 2, negative 12, and 0. So if I put that into my calculator, it'll be 2 and negative 12, and then 0, and then you will get 6 and 0. So in here we have the x1 equals to 6, x2 equals to 0. So which of these two would you think is the possible value of this? So for example, if you put the 6 here, this will be 6, right? Because 6 is the x, and then if you put it here, 6 plus 2 is 8, and if you put it here, there'll be 2 times 6, which is 12. 12 minus 2 is equals to 10. Right, so okay, this is 10 centimeter, this is 6 centimeter, this is 8 centimeter, right? But if you put the 0, if you put this 0 here, then this guy will be 0 centimeter, right? So we don't have right angle triangle then if it's 0. So which means that the value of the x is just this guy, because this is not possible. So this is going to be the final answer. Okay, so the final question here. Okay, let's read it together. A rectangular housing block has a perimeter of 64 meter and the area of 220 meters square. The length is x meters and the y is y meters as shown below. Calculate the possible value of x and y. So okay, so we have this x. This is the length, which is x, and y is the width, right? So the first information that we have is that it has a perimeter of 64. So as you know that if this is a rectangle, so this is going to be also x meter, and this is also going to be y meter. And as you know that perimeter means that you only need to add all of the side length, right? So x plus y plus x plus y, they'll be just 2x plus 2y, and they'll be equals to 64, right? So this is the first equation. The second equation is that we have an area of 220, right? 120. So the area of a rectangle is just length times width, so it's just x times y. So if I multiply x with y, they'll be equal to 220, right? So how can we solve this? Now we can see that this equation here, right, I can divide everything by 2, right? If I divide everything by 2, this is just x, this is just y, this is equals to 32. That's the first thing, right? And then I can change this, for example, as a subject of y. So if I move that x to the right side, and that'll be just y equals to 32 minus x, right? So as you can see that both equation, this equation and this equation, will have the same value of x and y. So which means that I can change this guy, this y, by this, because y equals to this, so this y you can change it into this, right? So yeah, let's change it out. So that'll be x bracket, right, 32 minus x, because that is the y, right? This guy is the y, so the y is to this, right? And then equals to 220. Okay, so I'm gonna change that. They'll be equals to 220. Now open bracket, we'll get 32x, multiply this and this, and minus x squared equals to 220. As you can see that we have a quadratic, right? So I'm gonna move everything to the right side. This becomes positive x squared, this becomes negative 32x, and this stays there, and that'll be equals to 0, right? So I can actually put the 0 over here. Now again guys, you can actually put this into the calculator, right? And it'll be 1, and then negative 32, and then 220. And you'll get 22 and 10. Is it? I think so. Yeah. So the x1 is going to be 22. x1 is equals to 22, and the x2 is equals to 10. So we have two values of x1, right, and x2. Now, in here, calculate the possible value of x and y, but it doesn't say, for example, if it's like the x is greater than y, because in the image, yes, we can see that it looks like that the x and the y are the same, but you can actually have, if it's not to scale, so you can actually have like this, right? So, or like this, right? So the length is going to be like shorter than the height or the width. It's actually the same thing. So which means that For example, if I have the x is equals to 22, what is the y, right? So again, you can use one of the equation. For example, I'm going to use this equation here to find the value of y. So if I have that, so which means that if the x equals to 22, so 22 plus y equals to 32, so y equals to 32 minus 22, they'll be just equals to 10. But if I have the x equals to 10, then 10 plus y equals to 32, right? I'm using this one here. I'm just substituting the x by 10. And here I'm substituting the x by 22, right? And that'll be y equals to 32 minus 10 and equals to 22. So, which means that the pairs, right, the pairs of x and y are 10, sorry, so it's 22 comma 10, which is this one here, 22 and 10, 22 and 10, and this guy, 10 and 22. So again, it doesn't say anything about whether the x must be greater with the y, although we can see that, okay, so it looks like the x is greater or yeah, longer than the y, right? So yeah, we can see it like that. But if it doesn't say anything, and if it's said that it's not to scale, then we cannot assume that x is greater than y without any information about, okay, for example, if this is a 10 and this is like 8, for example, it look obvious, right? This is 10 is greater than 8, but if it doesn't say anything, so we can assume that any of these two variables can be larger than the others, okay?